Okay, so just a reminder, I loaded these notes to Google Classroom. So if you have a printer at home, I think it'd be really helpful if you could print these off, just because it's going to help with some of the graphing today. I'm just going to jump right to it because I know that first video was long. It says for the graph below, estimate the area under the curve from x equals 1 to x equals 4. That's important information. That's going to tell you on every problem what limits you're looking for. X equals 1 to x equals 4 by drawing right endpoint rectangles. Okay, that's another thing on every single problem you have to know. Is it asking for right endpoint rectangles, left endpoint rectangles, or even midpoint rectangles? Okay. Use intervals of 0.5 units. That's the third piece of important information you need on every single problem today. You need the limits, what you're looking at, you need the types of rectangles, and you need the intervals. If you have those, you can do everything else. Okay? So we have a curve from 1 to 4. So I'm just looking at our graph here. It looks like 1 is going to land right here. 4 is obviously going to land right here. Okay, so these are the limits just from here to here. I want to find the area under the curve between those 2 points. So basically if I shaded in this region right here, that's essentially what it would be asking me for to find the area of. Okay, by drawing right endpoint rectangles, okay, we're going to do that. Use intervals of 0.5 units. So 0.5 units tells you how wide to make your rectangles, okay? So if I have 1, for example, okay? Let me just check my graph really quick. Yep, I'm good. Okay, so if I have 1, 0.5 means every 0.5 I want to draw my rectangle. So from 1 to 1.5 would be right here. From 1.5 to 2 would be right here. Let me just draw 3 right here. So just so we all know, this is 1, 2, 3, and 4. So 1.52, 2.53, 3.54. Okay, so I went every 0.5. That's where I made my marks. And I'm going to draw right endpoint rectangles. So my rectangles from 1 to 1.5, that's going to be one of my rectangles, needs to touch the graph at the right endpoint. So I'm going to start at the right side of that rectangle and touch there, and then I'm going to go over, because remember a rectangle's got to have a flat top, then I'm going to come over and down at 1. Okay, so that's my first rectangle. Then I'm going to go to my next rectangle, but remember it's my right endpoint, so I need to start at my right side, and that's where it's going to touch the graph. And then I go over and down to meet the other rectangle. Okay, my third rectangle, again, I start at the right endpoint of that rectangle. Then I come over and then down. Same thing for all of these, the right endpoint. And I'm going to come over from there and down. Now I'm at 3.5. I'm still, my right endpoint is where I'm touching the graph. Down. And then 4. So we just darken this in. So this is going to be a 4, and then over, and then down. Okay? So these rectangles are going to help us find the area under the graph. The thing here is, it looks like, just by looking at it, we've got these pieces above the graph here, if I were to color this in. Okay? Because this last question says, is this going to be an overestimation or an underestimation of the actual area? Well, it looks like if we take the area of all these rectangles and add them together, it's going to be an overestimate of the area underneath the curve, because right now we've got these little pockets that are above. This is overestimating. So I'm going to write overestimate for this one. Okay? And then I'm going to start calculating the area of each of these rectangles. Okay? One thing just to note here, because you're going to see this symbol a lot over the next few weeks, is the distance of the base of one of these rectangles. So let's take a look at this first rectangle. From here to here, okay, along that base, we're going to call that distance delta x. Okay? And then the height is going to be wherever that right endpoint matches with the height of this rectangle. Okay? So let's find the area of each of these rectangles. So I'm going to say delta x1 is going to represent the distance along the x-axis of this first rectangle right here. Okay? That's the same thing as if I were to take the area of this. Remember, our base was 0.5 because it told us in the problem we wanted to go intervals of 0.5. So 0.5 is our length. And our height, let's see, let me just mark this. This is going to be 1, this is going to be 3, this is going to be 5, just so I know where I'm at here. This is going to be 7. Okay, so this height of this first rectangle, where it meets the graph at the right endpoint, okay, if I come over, it looks like this is 0.5, it looks like it'd be 0.75. So I'm going to write 0.75. Okay, and you do that in your calculator, you get 0.375. Okay, now I'm going to go to my next rectangle, and that's going to be this one right here. I'll take the area of that, so I'm going to call that delta x2. The base is 0.5 times the height. Remember, we're looking at the height of this second rectangle. I'm going to call that, let's see, this would be 1.5, so it would land probably somewhere around 1.25, 1.25. So that's going to be 0.625. Delta x3 would be my third rectangle. I'm going to speed up a little bit just because these are all pretty much the same. Is 0.5. The height of that looks like it's right at 2. Okay, so that's 0.5 times 2. Delta x4 is going to be my fourth rectangle right here, and that's going to be base or length times width, or height, I'm sorry. And that height looks like it goes up to 3. So 0.5 times 3 is 1.5. Delta x5, I'm going to my fifth rectangle here. We're almost done with this one. That's going to be 0.5 times 4, which is 2. And now I'm down to my last rectangle right at the very end here. That's going to be delta x6. And that's going to be 0.5 is my length along the base. And it looks like 5.25 is my height. So that's going to be 1.25. Okay. To get the area, or approximate the area under the curve, we want to add all of these, areas together to get a cumulative total. Okay? So I'm going to say the area under the curve. When you go to your calculator and add all of our answers together, this plus this plus this all the way down, you're going to get 6.75. And when we're taking area, we like to make sure that we square our units. Okay, so that's going to be our final approximate of area under the curve, and we know that this is an overestimate. Okay, all right. Let's try another one. This one should be a little bit shorter, and this one's going to be, let me just move things around here. This one's going to be left endpoint rectangles. Okay, so let's look at those important pieces of information. We have our limit from 1 to 4. So I'm going to put a mark there and a mark there from 1 to 4. Left endpoint rectangles, that's important. And intervals of 1 unit. Okay, so every 1 unit, we're going to make a rectangle. So from 1 to 2, that's going to be a rectangle. 2 to 3, 3 to 4. The only difference in this one is these are left endpoint rectangles, which mean I need to make my rectangles starting from the left side of each rectangle. So my first rectangle goes up to where I hit the graph. I'm touching my curve right there. Now I'm going to go over and connect with my second unit right here. Okay? Now this rectangle from 2 to 3, again, I'm starting at the left side. That's so important. So I'm going to start at the left side of this rectangle, go up to where it meets the curve, and then I'm going to go over and then back down. Okay? Next one, I'm going to go up to where it meets the curve, over and down. It looks like this one, I only got 3 rectangles, so this one's going to go quicker. Notice, though, that we are missing these pieces, and this is still under the curve. Okay? So if we're not counting those, and those are under the curve, that means our final answer is probably going to be an underestimate. Okay? Because we're missing those pieces under the curve. okay? This is, remember, these, let's call these distances delta x, okay? And that's just, I'm just talking about this distance along the base. Let's call that the change in x, okay? So if I'm going to add up all my areas together, I'm going to say delta x1 is equal to 1, because that's my length of my base, times, looks like this is, we're going to have to look at our marks here, 2, 4, 6, 8. Looks like this goes up by 0.2 each time, 1.2, 1.4, 1.6, 1.8, 2, okay? So that looks like it's going to land at 1.246, and that's going to be 1.6. Delta x2 is going to be, length of my base is 1 times 2.2, and that's going to be 2.2. And delta x3 is going to be 1 times, let's see, that looks to be about looks like 2.5 actually. Okay, and that's going to be 2.5. Now we have to add all these areas together to get the approximate area under the curve. When you do that, you get 6.3 units squared. Okay? All right, I'm going to rush ahead to this third one because I know, again, this video is getting kind of long. I just want to make sure you know how to do this because you're going to see a midpoint one on your homework today. Okay? So this one says from 0.5 to 2.5. So let's see, where's that going to be? These look like, actually these markings look like 0.2, 0.4, 0.6, 0.8. So it's actually going to be 0.5 would be like right here. If we consider each one of these markings 0.2, 0.2, 0.4, 0.6, 0.8, and then 1, 0.5 would be somewhere in the middle right there, okay? And we're going to 2.5, which would be right here, okay? And it says use intervals of 1 unit, okay? So it looks like I'm going from 0.5 to 1.5, and then 1.5 to 2.5. This one looks like it's going to be a quick 2 rectangles here. So let me just draw these in. It says the midpoint of the rectangles. Okay, so this one's different because this is looking for midpoint of rectangles. Okay, what it means when you're doing midpoint is you have a triangle here and a triangle, or not, I'm sorry, a rectangle here, this first rectangle, and a rectangle here, that second rectangle. We want to know where the midpoint of those rectangles meet the curve. So let's look at this first rectangle, for example. We know this is a side, this is a side. Halfway between those, okay, would be the midpoint, which is like right here at 1. That's going to meet the curve right here, okay? And I just need to extend those kind of wings or that top out to meet, if I could draw a straight line, to meet the edges of that rectangle, okay? So now you're seeing that it's the midpoint of that rectangle that's meeting the curve, okay? Same thing on this second rectangle. We want to know where the midpoint meets the curve, which is going to be right here, okay? If I go over just a straight line to meet my side, and then another straight line, I'm having a hard time drawing straight lines today, to meet that side, it's going to look something like that, okay? So we want to know the area of this, and we want to know the area of this. Actually, this last part of this question isn't really valid for this one. Is it an overestimation or an underestimation? Usually when you're taking midpoint, it's a little bit, it could be either one, okay? So let's not worry about that for midpoints. So let's set up our 2 equations here, okay? So I'm going to have delta x1 is equal to, let's see, what's the length of my base? From 0.5 to 1.5 is going to be 1. And it looks like my height, if I go 2, 4, 6, 8, 10, looks like my height is going to be 0.9. Okay, and let's look at delta x2, which is, again, my base length is 1, but my height, let's see, 2, 4, looks like 0.5. Okay, let me just check, make sure I did that right. Yeah, that looks good. Okay, so again, area, we're just adding together our two answers. 0.9 plus 0.5 is going to be 1.4 units squared. Okay, so again, I know these videos were longer today, guys, but this is kind of the start of something really important that we're going to be talking about in calculus for the next few weeks. Remember to read the directions, left endpoint, right endpoint, or midpoint of your rectangles. That kind of dictates your problem, okay? Please reach out to me. Ask for one-on-one live help if you need it, or email me if you need help, and just let me know.